I know.
We have 15 minutes.
No, but we should study more.
So here's our next chapter is roots and powers, and the very first thing in our next chapter is a review of what you did in grade 9, which was the number families. And mathematicians decided on the following number families. Now the official symbol for the naturals is an N with 2 lines. The official symbol for whole numbers is a W with a whole line. The official symbol for the integers, most common, is the Z with 2 lines. But the Americans got confused, so they introduced the I because integer starts with I. Remember this from last year? And instead of being separate groups, which is what all of us try to do, when we have that list of numbers, you tried to put numbers into separate groups, but you ran into problems because some numbers you wanted to put into both. So mathematicians recognized that, and what they did is they have numbers that are in more than one group. So for example, the number 2 is a natural number, but it's also a whole number, and it's also an integer. So what we do with our number families is we just get more specific with our description. Q is the symbol for rational numbers. Those are any numbers that can be represented as a fraction. So the number 2 is a rational number because you could write the number 2 as 2 over 1. Q with a line. Q with an extra line. All of these have like the extra line symbol built into them. And every decimal that ends or repeats can be written as a fraction. So any number that can be written as a fraction is a rational number. Any number that cannot be written as a fraction is an irrational number. And irrational numbers, the symbol for irrational numbers,
It's like a 9-foot cube.
you know, Q with a line over top, or sometimes you have a little squiggle in front of the Q. These are decimals that go on forever but don't repeat. This includes many square roots. Square root of 2 would be irrational. Square root of 3 would be irrational. But square root of 4 would not.
Yes, and the reason is because
It's equal to 2, so it's a rational number. But square root of 5 would be irrational. Square root of 6 is irrational. Square root of 7 is irrational. Square root of 8 is irrational. But square root of 9
the square root of 773 is irrational, right?
And then there's some special numbers. Here's a special number you know. Here's a special number you don't know yet. But it's also on your
Wait,
calculator.
is that like 5's brother?
It's like they're twins
Oh, like middle child?
or cousins. Yes.
What's your favorite number?
My favorite number? I have lots of favorite numbers.
7.
I like 7. I like 3.
3 is a good one.
3 is a good one. 3 was my favorite number because in grade 6, well, this is a good story in grade 6. In grade 6, what they let us do every Wednesday afternoon was choose an activity that we wanted to do all afternoon. You could make bowls out of popsicle sticks, or you could join a cooking club and then make something in the kitchen, or you could go bowling, or a bunch of other things. Okay? So the one time I chose bowling, and then every Wednesday you walk to the local bowling alley and bowl. And the reason number 3 was my favorite is because one day, and number 7, so number 7 and 3 were good for this day. Because I started bowling, it's 5-pin bowling, and I started off with a strike. So that's very exciting. Got them all down. I went up the second time. Got another strike. Ooh, very exciting. Went up the third time strike, fourth time strike, fifth time strike, sixth time strike. I got 7 strikes in a row to start that game. I ended up being, the bowling alley had 4 lanes. I was in lane 3.
Really?
And in lane 3, I bowled a 303 in lane 3.
7 strikes.
So 7 strikes in a row that day. So number 3 was very exciting for me for a little while after grade 6. I happened to be, it's a small town, I got the highest bowling score in the entire town for that week. Oh, Yeah, they were, it's like, way back and they.
Not satisfying.
No, 6.
Oh.
6 was a big one. So it was very, very exciting. So the number 3 was exciting for a long time. But I do like the number E. Just because how many numbers have a letter in their number? So we represent all these number groups by circles. Because the natural numbers are inside the whole numbers. And the whole numbers are inside the integers. And the integers are inside all the rational numbers. The irrational numbers are a separate circle, so you have rational numbers and irrational numbers as separate, and sometimes this is put in a big box to talk about the real numbers, right? And the one thing we don't talk about in high school math is the non-real numbers. But they exist.
But they're not real.
They are right. They're called. You guess what they're called? Imaginary numbers.
Whoa.
They exist.
How do they exist? They're imaginary.
I know, it's crazy.
So would they exist if we didn't
So
think about
do you want to know an imaginary number?
Yes.
I?
I is an imaginary number. It's even on your calculator.
Well, you think about it, anything can be an imaginary number.
And if you want your calculator, you have to change your calculator because usually your calculator can't do stuff like this. Right? That's not allowed unless you invent imaginary numbers. And this is what I is equal to. The square root of -1. It's an imaginary number.
Is that even possible?
It is. If you, and there's a problem because a lot of people didn't believe in them, probably because they were called imaginary numbers. So they've changed the name a little bit. Sometimes they're called complex numbers.
That's lame.
You like imaginary better?
Lame.
Yeah.
Yes.
How does the square root for a negative number work? Because if you times a negative by a negative, it's positive.
Except if you times I by I, you get -1.
What about like
And it doesn't exist and it's not real. However, there are real life problems that you can only solve if you use unreal numbers.
You know, sometimes you could be making it up. Like I square
I
root
could be
nine.
making this
Yeah.
up, but
I tried doing the square root of -1 and just said that.
Yo, can we have a review on the suitcase method?
Call them Ellie. And birds.
Birds snap.
oh, try it again. Use the wrong negative sign.
What?
I got his calculator to do square root of -1. What? Play that. Check it out. What does it say?
There's like some Halloween magic here going on, JR.
Okay, check this out. Square root of -4. What do you think it's going to be?
Not
No.
Negative 2.
It's going to be P. 2I. Put it in there.
So much potential.
That's what I was gonna ask. How would it
It doesn't.
That was on the
Negative numbers don't have square roots unless you use imaginary numbers. But we don't do that. So for us, we're going to say that this is not possible. Right? But now Gage's calculator is screwed up because it no longer says it's not possible. His calculator now tells him it's equal to 2I. You want me to set it back to regular?
Yeah,
so it's
sure.
not an imaginary calculator.
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 There we go. Back to
Calculator.
So now if you do the square root of -4, it will tell you non-real answer.
Hunter,
Square root of -4. I should tell you it's not possible. Okay. Question?
Can we get a review on the suitcase method?
I know, right? Like, always lying, right?
Come in at lunch on Saturday for a review on it.
Okay. So we are going to use the symbols. Rational or irrational. I'm going to color code them too. I'm going to use green for irrational, so you really can see it. What do you think? 3/4. Rational or irrational?
Rational.
That is rational.
How do you tell again?
If it can be written as a fraction, which includes decimals that repeat or decimals that terminate, that's a rational number. This one is irrational.
What are these symbols we're drawing right now?
The symbols for rational and irrational.
You're made of
Did I miss it?
That's right. I just made, this is such a fun class because I just made this whole thing up and
This
this
next one is
just makes sense to
rational.
me.
Rational. I is irrational.
This one is rational.
Okay, I get it.
I is irrational.
Pi is irrational.
See that? Yeah.
4 nines?
That's irrational.
Why is it all?
That's
wait.
rational.
Yeah,
Because it can be written as a fraction. Square root of 4?
Rational.
Rational because it's equal to 2.
Okay. Sounds good. Irrational.
Irrational because the dot 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 means it goes on forever. Is it repeating? We don't see any pattern repeating itself. It is irrational. But this one, you do see a pattern. This is equal
Hold
to
up.
negative 1.13.
How is 5.456 rational?
This would then be rational.
Oh, bless you. Wait, hang on. How is 5.456 rational?
Because it ends. You could write this as 5 and 456 thousandths.
Oh.
You could write it as a fraction that way. Any decimal that repeats, do you remember how to change repeating decimals to fractions? This is negative 1 and
Oh, I don't see the hair though.
1399.
Talk like him though. Like he's so like monotone. Talks like that. So like
Hey, I mean in gym class.
Okay, we're going to color code this as well. We're going to start off with natural numbers being black, whole numbers in red, integers in green, rational numbers in blue, irrational numbers in purple, and real numbers.
Mr. JR, just a quick question. I don't know where did your collagen go, whatever you call it?
It's over there.
what? Oh wow, interesting.
Interesting.
Sounds good.
That bucket of candy.
Wait, yeah, wait, you're giving us candy. That's not wait.
Yeah.
Yeah.
What just happened?
Here we go.
Volunteer him.
He is.
Candy.
What I find helpful for these is when you have to list all the families something belongs to, is finding the smallest one and then thinking about these circles. If the smallest one is n, then you will also have w, I, q, and r. If the smallest one is integers, you will also have rationals and real numbers. So when figuring this one out, is 44 a natural number?
Yes.
Yes. So you would have
Oh.
natural numbers, whole numbers, integers, rational numbers, and
You're wrong for that. You're wrong.
real numbers for this one.
I'm just gonna go 6 out of 6.
Negative 3, is that a natural number?
No.
Is it a whole number?
Yeah.
Yes.
No. The whole numbers are 0, 1, 2, 3. This is negative. So the first one is integer quotient.
Good morning, my favorite husky. So if I do an analysis that
Zero.
are the official winner, decorate the door content.
Until the end.
I